Okay, so we need to keep our problem solving skills sharp. Okay, so that's why we are taking a contest today. Okay, context. I was reading about I was reading Lang Chain Docs, so that's why I said context. Anyway, let's go. Let's start. Interesting. I'm sure there are already some people who submitted first question. Come on. Hmm. Interesting. Unique middle element, maximum valid pair sum, minimum operations to count distinct way. Seems like the third and fourth problems are going to be DB as usual. Mm-hmm. Finally. Finally, man. Okay. Come on. Enjoy. God. Know what's going on. طب ايه؟ انا ممكن نعمل شو، بنعمل ايه تاني على اساس انه تكون حملت لما نوصل. Maximum prefix, I guess. I only care about the maximum prefix. Yeah, the maximum prefix, maximum. And max. Environmental size, vector. Max one. j minus I is أكبر من أو يساوي k. So I minus k is k. So that is the element. I minus k, that's k. Okay. I minus k, that's k. So this is the element, and anything behind works. Okay, so so answer equal max answer fast nums fill up I and ref of lower. Okay. I found a mistake. You are given two binary strings S1 and S2 of the same length in. You can perform the following operations. S1 any number of times in order. Choose an index I such that S of I is 0 and change it to 1. Choose an index I such that the I from 0 to n. Both S1 of an I is 1 of an change both characters to 0. So I can change 0 to 1, or I can change any two consecutive ones to 0. change any 0 to 1, change any two consecutive ones to 0. Again, there are a number of operations required to make s1 equal to s2. If it's impossible, return -1. Yeah, here we can just, we need one operation. Here, he needs the minimum number of operations, but yeah. I can change it into okay, so here output is 3. I change this to 1. I need to make this one 0. So إذا حولنا we convert the 0 to 1, we got 1 1. And then I can convert both of them again to zeros. And then I can convert that again to 1. And that's 3 operations. Because I cannot make the 1 0. It's not possible to make the 1 0. So it's always, and I have a 1 that should be 0. So it's going to be if whenever we have a 1 that should be 0, I will look at the number before it. If this number was, we have multiple but the number before it should be 0. And it's, for example, 1. And that's already okay. So if the number before it is 0 and should be 1. If the number before it is 0 and it should be 1. If the number before it is 0 and it should be 1, we have to do 3 operations like this. If the number before it is 0 and should be 0, it's 2 operations. So we need to write some cases first. If we have 1 that should be 0, then we have multiple cases, okay? So how are we going to represent these cases? Number 1, it should be 0. طيب عندك 1 0 قبله ممكن يكون في 0 0. Okay, that's a case. Another case is 1 should be 0 قبله ممكن يكون في مثلا واحد it needs to be واحد. That's another case. ممكن يكون في عندها 1 that should be 0 and قبله ممكن يكون في 0 that should be 1 أو في عندي مثلا 1 0 قبله ممكن يكون في 1 that should be 0. اوكي طيب هي حكينا نحن نعرف إنه 0 1 0 هي الكيس بتكلف 3 حكينا. ايش نكمل خلاص لأنه هون بهي الكيس هي واحدة تصير 0. the only option is I have to make this one, then I will use both of these. But maybe it's better to look at the next number, because maybe the next number, for example, is okay. So every time we find a 1 that needs to be 0, we have to consider dealing with matching it with the number before it or after it. Okay, we have two cases and we will choose greedily. We will choose greedily because it's either the answer is going to be 3 or 2, for example, 1 or 2 or 3. هي بس خلينا نقول إنه هي 3. الكيس عبارة عن 3. طب هي الكيس حولت 2 ل 0 بتاع الموضوع. ف this case is 1. In this case I will convert both to the 0. Okay, I have to convert both to 0. Both are going to become 0. Then I'm going to switch this one to 1. So that's 2. Okay. Here, I'd switch this to 1. To zeros. Yeah, so that's 2 again. They've got 1, 2, 3. طيب. If I fixed the current one with the number that comes after it. لما اخذ جريدي فانا صلحت هذا الشيء. معناتها لازم اصلح مثلا ممكن اني انا كونسيدر اني اصلح الوحايد تصير 0 بس بالاول يعني. اوكي. So we are going to fix the ones that should be zeros first. We will focus on these only. We'll ignore the other ones. I think this works. If we fix the one that should be zeros first, probably this is the solution. I'm not sure if it's going to work or not. Probably yeah. Yeah, but there might be impossible answers. Well, impossible answers are only if n is 1, I guess. It's like this. Because for n is 2, n is 2, we can have 0, 0, we can have 1, 0, we can have 1, 0, we can have 0, 0. We can have anything. I think this is the solution. Yeah. This is probably the solution. Was if s1 full I equal 1 and the s2 for the y equal to 0, then we need to do something. We need to do something. We will keep and answer 0. Come here and we say we have two cases here. Okay, I have two cases that I should consider. It's either 1, 0, 0, 1, 1, 1, or 0, 0. So what is the best way to implement this? Int function get old. God. got 1 plus 1 plus 1, that's 3. Next one, that's 3, 1, 1, 1, 0, 0, 0. Okay, the final hurdle. You got 40 minutes. You are given 3 strings. Word 1, word 2, and target. Count distinct ways to form target from 2 strings. Okay, I know this one. I know this problem. But it's been a long time since I did something similar. So you're giving 3 strings, word 1, word 2, and target. Your task is to count the number of ways to form target by choosing characters from word 1 and word 2 under the following condition. For each character of target, choose one machine character. For each character of target, choose one machine character from the chosen indices from word 1 must be strictly increasing. The chosen indices from strictly increasing. At least one character must be chosen from both word 1 and 2 ways are considered different if for at least one position in target. Ways are considered different if at least one position in target. The chosen character comes from different string or different index. The number of ways is the answer. Maybe hard to ABC. Nice, bro. Okay. So this is probably going to be dynamic programming with probably it can be solved with a recursive. You don't need to make iterative dynamic programming. First, if the character exists in one word only, then we are forced to take that word. We don't have the luxury of choosing. Okay, if the character only exists in one word, we have to choose it. We have to choose. Yeah, target.length is 100. Okay, it's 100. So yeah, we can do recursiveness. We can do recursiveness. So like let's say that this is target. Okay, we are iterating over target. Right now I'm on this character. This character could have two options. It's either I choose or I get this character from word 1 or word 2. Okay, so I need to know where my index is at in word 1 and word 2. So we need 3D tables. With 3 indices. And also I need to know, for example, I need to know where is the first C after index J, or where is the first character C after index J, because this is going to optimize the solution. Do I have to do this? No, I don't have to do, but we will try. And if it didn't work, we'll do the optimization. It's here, so it's like this index is there. It's there. Then I need to make the next character, so I will go to the next character. I'll do 2 for loops to check. I'll try both of them. That's it. Yeah, this problem is easy, I guess. The problem is I don't know. I'm not used to implementing solutions here in LeetCode, but yeah. Okay, so on 1 or 2 in target, we will have a function. It's also int. Okay. And what we are going to do is we console basically r equal to 0. I'm not very good at OOB in C++. Oh no. Let's check this is even correct. Yeah, that's part football declaration. Sorry. The number function is not returned. That's probably what it's. I'm sure there is an easier way to do this, but anyway, you don't have much time. Yeah. I like the number of ways. let's take, yeah, you know, you need to subtract something. I forgot. And x is not equal to 0, and y is not equal to 0. X is not equal to 0, and y is not equal to 0. Okay. We got 5, yeah, we got 5. We got 4, we got 2, and we got 1. This is the answer, but we need to do db, and we need probably db alone is not going to work aslan yet, because we need to optimize these two for loops anyway. Come on. Please tell me this could work, please. have to try all of them. Can I optimize this? Probably if we need to optimize this, it's going to be iterative DB. بس كمان بدنا نعمل له optimization، صار لازم نطلع على iterative DB. بس حاليا we cannot optimize this. Yeah, I can try all the positions. I can calculate all the positions before. But it's not going to be a big optimization. So, let's look. We have 4, we have 2, we have 1. This looks promising. So let's test it. Probably time limit exceed. Oh, hidden test case. Okay. Can I use the test case in? It's hidden test case. Yeah. Okay. اسمها جهة تعليمية بس لا accepted. Okay. Nice. Nice. Okay. So let's try to explain the problems really fast. What is this? Oh my God. What? Are you kidding me? Expected true. صح، ما احنا بنبدأ الاندكسنج من الزيرو. اه اوكي. اوكي طيب. Okay, so first of all, this problem he's asking you if the middle number is unique, and he's going to give you an odd length array anyway. Okay, he's going to give you an array of nums. The length of this array is odd. Okay, and indexing starts from 0, so all you have to do to get the middle number is to do n over 2. Okay, for example, if we have an array of 7 elements, 7 over 2 is going to be 3, which is exactly the middle element because we start indexing from 0. Okay, so we get this middle element and then we count how many occurrences of this middle element we have by initializing a counter variable. Okay, if we have only one, we will return true, otherwise we return false. Okay, the next problem is asking for the maximum valid pair sum such that, okay, so we have a pair of indices I and j. We have an array of nums of length n, and we will be given an integer called k, and we need to return the maximum value of nums of l1 plus nums of j among all valid pairs. Okay, so basically it's like we have an array like this, and we need to choose any two pairs such that the distance between them is bigger than or equal to k. Okay, so case 2, for example, if case 2, k is equal to 2, then all we have to do is we will, for example, we will say that the first number is going to be called I and the second is going to be called j. Okay, so we will brute force j while we are iterating the array. So we will assume that this is j. Okay, so what is the best I that we can take? The best I that we can take should at least have a distance of 2 from the current j. So it's going to be somewhere here, and okay, so we don't have anything here, so we'll skip this one. We will go to the next index, for example here. Okay, so j is here, so we need to check what is the best I or the maximum I that we can take, because we want to maximize the sum of pairs. Okay, we are brute forcing j and we are checking the best I that we can take. We brute force one and we check the second greedily. So if we are here and case 2, j minus I must be, Okay, so j minus I must be akbar min k bigger than k. This means that we can take any number that is here or before. Okay, with this number we can take any number starting from this index and any index before it. Okay, and also we will, for example, if j is here right now, if j is here, we can start at this index and anything before it. And if j is here, we can start at this index and anything before it. Why? Because k is 2. So let's say that this is, for example, 0, 1, 2, 3, 4. This is 4, index 4. Okay, this is going to be index 3. This is going to be index 2. 4 minus 2 is 2. Okay, so any number, any I that we take from here is going to be it's going to satisfy the constraint that we have, that j minus I must be bigger than 2. Okay, and again, if j is here, we can take any number starting from this index, okay, and any number before it. So all we need to do, we don't have to try this j with all these indices. Okay, we don't have to try the current j with all of them. Okay, because if we did this, the complexity is going to be n squared. Okay, because each time we will pick j and we will try all the numbers, the complexity is going to be around n squared. So what we can do is greedily find the maximum number in this range. Okay, and we can see that we are always the range that we are searching from is always going to be a prefix. For example, as you can see here, this range is a prefix, and if we, for example, again, if we pick this as j, then we need to search here. Okay, and this is a prefix, so all we need to know is what is the maximum number in this prefix. Okay, that's all we need to know. What is the maximum number in this prefix? So that's what I did. I made a prefix array. I calculated the prefix maximum. Okay, and then I fixed j. For example, I fixed j here. I checked which prefix I need to find the maximum. It's this prefix. When k is equal to 2, it's going to be this prefix. Okay, and all I did was that I calculated the maximum answer. The current number plus the prefix maximum of the lower bound. Okay, the lower bound is basically I minus k. Okay, so lower bound is going to be this index here, this index. I got the prefix maximum for this part of the array. Okay, and I added it to j. I added nums of j plus nums of the maximum number here. So yeah, the third question is minimum operations to transform binary string. So we have two binary strings consisting of zeros and ones. We need to convert the first string, which is called s1. We need to convert it into s2. So we can we have two operations. We can convert any 0 to 1. Okay, and the second operation is that we can convert any two consecutive ones to zeros. Okay, so if we can convert any 0 to 1, this means that in s1, the first string, any 0 that must be 1, this is an easy operation. We know it's going to cost 1. That's okay. If we have 0, 0, we don't need to do any operation. If we have 1, 1, we don't need to do any operation. Okay, so we have three cases till now. This case is easy. We will just make the 0, 1 and that's it. This case also is easy. It's already done. This case is already done. The only problem is when we have one, or when we have one that must be 0. Okay, we cannot convert 1 to 0 directly, but we need two consecutive ones. Okay, we need two consecutive ones. So I did explain this here. Okay, yeah. So if we have one and one that must be 0, okay, I split this case into 4 cases. What are these 4 cases? Okay, so this is a one that must be 0. Okay, we need to check either the previous number or the next number, because we need we need another number in order to convert this one to 0. So for example, let's focus on the previous number only. Okay, it's exactly the same for the next number. So here we have one that must be 0. Okay, and the previous number is 0 and it should be 0. So in this case, in order to make this one to 0, okay, in order to fix this case, it will cost us 2. Why? Because we have to convert this 0 to 1, and then we will have 1 1. Okay, then we will have 1 1, and then we can convert both of them to 0. Okay, so that's 2 operations. I have to convert this to 1 and then both of them to zeros. Okay, so it's going to cost 2. Also in this case, it's going to cost 2. Why? Because here I need to make this 1 0. So I have to convert both of them to 0. Okay, and then I have to convert this 0 to 1 again. So it's like I have 1 and 0. So it's also 2. Okay, this case is in the samples. This case is already on the samples. We have to convert this one to 1, so we'll have 1 1, and then we have to do we have to convert both of them to 0, and then we have to get back this one to 1 again, so it's going to be 1 0. So it's going to cost 3. Okay, and also the same thing for this case. Same thing for this case. It's going to cost 1. It's going only to cost 1 because we can convert both of them to 0 immediately. Okay, so we have 4 cases. Okay, we have 4 cases that we need to consider whenever we have a one that must be 0. So that's basically what I did. Okay, like I looped on the array. Whenever I found something that is 1 and it should be 0, I tried to convert this one to 0 either with the next index in the array, okay, or the previous index in the array, whichever is going to give me the minimum cost. So I tried both, the I minus 1 and I plus 1, and for each one of them I got the cost based on the case. Which case is it? Okay, we always know that I have one that must be 0, but which case is it for the next index or the previous index? Is it 0 0? Is it 1 1? Is it 0 1? Or is it 1 0? Okay, based on the case we will return the cost here. For example, if x is equal to y, this means that the cost is 2. Why? Because we know that if x is equal to y, as you can see here, we have 1 1 and 0 0, so the cost is 2. Okay, this case is when x is 0 and y is 1, which is this case. I have the current number is 1 and it should be 0, but the previous or the next index is 0 and it must be 1. This costs me 3. Okay, so I pick the minimum, whichever is the minimum I pick. Okay, and then after I know what is the minimum operations, I apply them. Here I am applying the operations. Where is it? Here. If it's the first, which means the previous, okay, then I apply the operation to the previous index and to the current index. Okay, the current index is already fixed with the previous index. Otherwise, I will apply the operation to the next index. Okay, after we do this, this means that we fixed all the ones that should be 0. Okay, which is the tough operation. Okay, the hardest thing in this program, converting 1 to 0. After this, all we have to do is iterating over the array and converting any zero that should be 1 is going to cost 1 operation. So that's what we did here. Okay, next we have this problem. It's a dynamic programming problem. We need to calculate the number of ways that we can form the target using word 1 and word 2, and we have a couple of constraints. Okay, like the indices from word 1 must be strictly increasing, the indices from word 2 must be strictly increasing, one character must be chosen from both word 1 and word 2. So what I did here is a basic dynamic programming. I have 3 indices, I, x, and y. I represents the current index for the target, X is the current index for word 1, Y is the current index for word 2. What I did is I brute forced all the possible ways or paths. Okay, for example, if we will look at this example. Okay, we have the target, which is A, B, C, and we have word 1, which is A, B, C, and we have word 2, which is B, A, C. So basically what I did is that I have an index iterating over this word, the target. Okay, I start with A, so this means that I have two options. I can start here or I can start here. So that's what I'm doing here. I'm checking where can I start. Okay, so we started with X, which means the current index here, and Y, the current index here. So first we start with index X equals 0 and Y equals 0. Okay, so when we start, we check. How can I start? I can start from here or I can start from here. If, for example, I decided to start from here, this means that I will go, and I here is equal to 0, I is equal to 0. If I decided to start from here, this means that my transition, my dynamic transition, my dynamic programming transition is going to be I is going to be 2, okay, and X is not touched because we did not choose this A, we chose this A. So X is going to be 0 and Y is going to be 0, 1, 2. Y is going to be 2 because we already picked this A here. So we need to set Y to 2, which means that we cannot pick any character from here. Okay, we can pick characters only after 2. Okay, so this is the transition that I make. Okay, after making the transition, you need to increase the answer for every transition that you make. For every possible path, you will add the answer. Okay, and this is the dynamic programming step here. And also at the end, when we reach I equal target size, we need to check if X is not equal to 0 and Y is not equal to 0. Why? Because we have a constraint here saying that at least one character must be chosen from both word 1 and word 2. Okay, so if X is 0 or Y is 0, this means that we did not take anything from X or Y. Okay, and so we don't need to count this. We don't need to count this one. Okay, so if I equal target dot size 1, okay, actually we should have we should return 0. We should do this. Yeah, we should return, like, I don't know how this one did not go for an infinite loop. And we need to do this. If X is not equal to 0 and Y is not equal to 0, else return 0. Probably we should have done this. I don't know why there was no stack overflow. There is no stack overflow because because the goal is going to be something out of index. Then we will search for something similar to goal. We won't find any, so we won't call the answer. We won't call solve. Yeah. Okay. Anyway, we should do this. This is the correct way. Okay. Thanks for watching, and let's check our ranking really fast. Where am I in the ranking? Probably around 4,000 or something. Where am I? Oh, nice. Lift my me. Okay, cool. Cool, guys. Cool.